All right, learning target 3. This is the graph, the chart you'll need. But here's the example. We'll look back at that chart in just a second. Learning target 3, you're going to be graphing a polynomial function and talking about a lot of its features. The first question, standard form. To put that function in standard form, you simply take the highest exponent, list it first. Then the term that comes after that would be the next lowest exponent. So in this problem, the highest exponent is x to the 4th. So x to the 4th would go first. Then there is an x cubed, so it goes next, minus 2x cubed, and then minus 5x squared. That's quote unquote standard form. Now the degree. This is something that would have came up in that scavenger hunt. The degree is the highest exponent of the individual terms. So when you look at this problem, x to the 4th is the highest, so it's a degree 4. It's a degree 4. And I use that to name it. Just like in biology, there's a classification system, kingdom, phylum, class, order, species. I've probably got them mixed up. But they've got a classification system. Polynomials have a classification system, and it's this chart. All right, so degree 4, it's got a name. According to the chart, a degree 4 is called a quartic. This is a quartic. They're also categorized by the number of terms they have. So let's look back at it. How many terms does it have? It has 3 terms. So it would be called a 3 terms trinomial. So this is a quartic trinomial. That's the classification system. Quartic trinomial. All right, so you can see you'll just need to either copy that chart down, make a note, and memorize it. They're pretty intuitive. You probably know most of them. What's a degree 1 called? Degree 1. No, degree 1. Degree linear. It's a y equals x plus 4. X has a degree 1. X has an exponent of 1. What's a degree 2 called? X squared. Quadratic, you know that. Cubic, that's not too hard to memorize. Cubic. Degree 5. And 6. All right, and yesterday we talked about the other term. If it's one term, it's a monomial. If it's 2 terms, it's a binomial. 3 terms, trinomial. 4, 5, 6, 7, 8, 9, they don't have a special name. It's just called a polynomial. It stands for many. So I'm okay if you just say, for a 4 term, polynomial. For 5 terms, polynomial. Okay, all right. Grab your calculator, and we're going to need to graph this to do the rest. All right, y equals, clear out the old one. Let's see, x to the 4th, x caret 4. If you have an old calculator, an old operating system, when you type x caret 4, it's probably going to look like that. And that's fine. If you have a newer operating system, it's going to take that 4 and put it in the exponent. All right, then minus 2x cubed. No matter what calculator you have, it has this feature. There's a button for the little cube. You might have noticed it already. It's in the math feature where you do your fractions. It's option 3. So just a little tidbit. You could do the caret 3, and that's fine too. But minus 2x cubed, and then minus 5x squared, it, of course, has its own button right above log. Double, triple, quadruple check this before you do any problem. If you make a mistake typing it in, it's going to affect everything. All right, you ever heard the measure twice, cut once? Building? No. Measure whatever you're going to cut twice before you cut it, because then you might mess. Anyway, look at it 2 or 3 times before you hit graph, but then hit graph. And then I'll hit zoom 6 to get back to the standard window. Zoom 6. Zoom. Come on now. Zoom 6. All right, that's typically a 10 by 10 window. That's what you're going to see. Zoom 6. You're responsible for changing your window now. So where do you go to change that window? It clearly doesn't go low enough. You go to your table and you look at what x value roughly. Negative. It's going to x value 2 or 3. It's going down. So far I can't see it. So look at x values 2 and 3. The window or the y values say negative 20 and negative 18. So I'm going to change my y min from negative 10 to say negative 25. I'm going to go a little further than what it says on the table. So y min negative 25. Cross my fingers. It may work. It may not. And that was enough. All right, so again, you're responsible for changing your windows now. All right, now interpret your turning points as relative max and mins. This point right there, the point I just drew an arrow to, that's a turning point. The graph's going down and it turns around. Would you think it's a maximum or a minimum? From our quadratic work, that'd be a minimum, right? Okay. It turns around again right there at about what appears to be 0, 0. That'd be a maximum. And then it turns around again here at the bottom for the last time. So it's a degree 4 and it has the 3 turning points. To find them, it's a lot like finding a 0, the left bound, right bound. The left bound, right bound, and the calculator will find them. You just have to find them one at a time. All right, so let's erase that. Let's find the first one, this one right here. Go to second count minimum. Second count minimum. Second count minimum. All right, and I'm going to move the cursor left of that blue arrow. Good enough. Hit enter. And then I'm going to move the cursor until I see the cursor turn, until I see it turn back up. I clearly saw it turn back up. So I'm going to hit enter to set my right bound, and the calculator is going to search between those 2 points that I just hit enter on and find the minimum, the lowest point. So don't guess, hit enter one more time. And your minimum is -1, -2. Now, is it the lowest the picture ever goes? So it's called something else. It's called a relative minimum because it's not the absolute minimum. It's just relative to the points around it, it's the lowest spot. So relative minimum is the point -1, -2. All right, now we're going to go back and find the other turning points. So second count, I'm going to find the next turning point, which is a maximum. So second count, maximum. I think it's 0, 0. I mean, it sure looks like it's turning at the origin. And when I set my left bound, I need to make sure I'm left of 0, 0. So check, hit enter. Then right bound, hit the right arrow until it turns. Enter twice. Oops, I'm sorry. I messed up. I hit minimum. I hit second count minimum. That was my fault. Let me back up. Second count maximum. Must not have hit down enough times. All right. So left bound there. Right bound there. Now, do you remember when we got those answers that said e to the -6, e to the -12? Do you remember what those were? Those were zeros. Those were zeros. It was a scientific notation, times 10 to the -6, times 10 to the -12. But it's zeros. I can't explain it. I don't know why it does it. But the x is 0, the y is 0. Okay? Your turning point is 0, 0. Your turning point is 0, 0. You see the e to the -6. You see that, and yours might even say a different number. I can't explain it. But your turning point, the relative maximum, because again, it's not as high as it ever gets, is 0, 0. Look. Your relative maximum is 0, 0. Why is that a relative? Does the picture go higher than 0, 0 anywhere else? Yeah, on the left and right, it goes up forever, right? Okay, so it's relative. Now, this last point is a minimum. Is it the lowest relative minimum? This last point down here at the bottom, which you can't hardly see anymore, is that the lowest it ever goes? Then it's called the absolute minimum, and it's going to affect your rank. All right, but let's find it. Second count minimum, set your left bound anywhere that is left of the point we're trying to find. Hit the right cursor until it turns. Hit enter twice. And you can't see it because of the little cursor. That's a -23, okay? That's a -23. So the turning point is, and even last period, it said 2.499999. I don't know why it does that, but that's 2.5. And it's the absolute minimum. 2.5. And with these decimals, 0.4375, it's up to you where you round your decimals. But if there's decimals, you need to put decimals. If you choose one decimal, it should say 0.4. If you choose two decimals, what should your y value say? 0.44. So again, it's up to you what decimal you choose, but if you're going to use two decimals, you got to look at the third decimal and round it up or down depending. All right, so the absolute minimum is negative 23 point, I'll go with two decimals, 0.44. All right, where to go next? All right, let's do familiar stuff, domain and range. Domain and range. 3D, what's the domain? What can you plug in for x? Here, here, and here. Is there anything that says you can't put a number in those spots? No, so once again, your domain is all real numbers. Just like a quadratic, your domain is all real numbers. What about the range? I'll remind you, this is the picture. Y value. There was an absolute minimum, right? A lowest it ever got, and it was the negative 23.44. So what would your range be in that situation? Exactly. Y is greater than or equal to, y is greater than or equal to the absolute minimum, this y value, negative 23.44. Most of this target is interpretation, okay? It's all keystrokes on the calculator, but it's interpreting what you're seeing. All right, let's hold off on the end behavior and increasing and decreasing, and let's tackle the picture, okay? Try to get the picture on your paper. You need to count by twos for this to fit. It still won't fit, but it's close enough. That's a 10 by 10 graph. All of them are 10 by 10. Go to your table in the calculator and pull out any points that will fit on your picture. Negative 390 will not fit, but negative 212 will. When I say count by twos on your y-axis, but you don't need to count by twos on your x-axis. All right, so how do you graph negative 2, 12? You go left 2 and up 1, 2, 3, 4, 5, 6. Up 6, that's negative 2, 12. Negative 1, negative 2 would be left 1 from the origin and down 1. Left 1, down 1. Remember, you're counting by twos on the y-axis. 0, 0 is 0, 0. One, negative 6. 1 down 2, 4, 1, negative 6. Would be down 3. 2, negative 20. Again, that's a 10 by 10 window. So right 2 down to the last bar, down to the edge of the graph. That's down 10. 3, negative 18 would be right 3 down 9. All right, and then we'll scroll down and see. Will 4 fit? No. 448. It won't fit, but it's important to know it's 448. It's important to know that it was negative 390 on the left side. It's important to know that, even though it won't fit. All right, the other things that are important to your picture is where it turns. Let's make sure we've got our turning points. Let's see. Yeah, we graphed negative 1, negative 2. We graphed 0, 0. We need to graph the 2.5. 2.5, negative 23.44. So 2.5, I'll use red for this. Right 2.5, down roughly 12. Close enough. Close enough. But that's where it turns. All right, now I'm going to connect the dots while looking at the picture. That's probably the best idea, is to have the picture in front of you. And watch me connect them once, okay? Watch me connect them once, then you can do them all on your own from then. But I'm going to start going down and turn and turn and turn at the turning points. But then, this is the part I wanted to make sure you were watching. I see this every year. Where does the function, where does it go after the 0.3, negative 18? It goes up to 448. So be careful. This is what I see every year. And I'm going to count off for it, because as soon as you do that, right there, you're saying that the 0.4, negative 9 is on the picture. Okay, so just be careful. When you finish this graph, it's going to 448. It's almost vertical. I mean, it's got an ever so slightly slide to the right. Okay, and on the left side, where's it going? Negative 390, so don't do that. It happens every year, be careful. Send it to negative 390. All right, so what's important for graphing? The points in the table and the turning points. All right, you try to connect it now that you've got them graphed, and then we'll answer the final pieces. I'll pause the video so we don't waste time on that. All right. Now let's answer the last two parts. Part 3C, the in behavior and the increasing and decreasing intervals. In behavior. You read a graph like you read a book from left to right, okay? So when we're doing the increasing and decreasing, we're going to read it from left to right. But the in behavior is asking a question. What's the function doing at the end? On the left side, after it does all the twisting and turning, so we'll scroll down and pull the picture back up. After it does all that twisting and turning, on the left side, where does this function go forever? Up. Up. On the right side, after it does all the twisting and turning, where does it go at the end? Up. All right, so the words I want you to think, you're in an honors class, so the words I want you to think are left, up, right, up, but those are not the words I want you to write. Some of you are headed to pre-calculus, and then you're going to get into calculus. You're going to be using the following symbols in limits as x approaches infinity, okay? All right, so let's think about that phrase. As x approaches, let's say negative infinity. As x approaches negative infinity. I'll write that. So the approaches is a arrow. X approaches negative infinity. Look on the x-axis. As x slides toward negative infinity, what direction is that? That's on the left side of the graph. Agree? As x moves towards negative infinity, that's the word left. What about as x approaches positive infinity? That's the word right. So as x approaches positive infinity is the word right. Now the question, what happens on the left side? So finishing this problem, what happens on the left side? The function goes up. The function approaches up. What would up be? Positive infinity. And then to finish this one off, the function approaches positive infinity. As it goes right, the function goes up. So again, positive infinity. All right, everything that was written, I think I kept my colors. No, I think I changed it at the end. It was green then red. I said anything in green and red is on every answer. The blue is what you have to interpret. Your in behavior is always going to be this question. What happens on the left? What happens on the right? And your answer is going to be it goes up or it goes down. Okay? So I'll kind of highlight that too. I think will be in every answer. The blue is what you have to interpret. So you might want to write this little cheat sheet down somewhere. Left is as x approaches negative infinity. Right as x approaches positive infinity. Up, f of x approaches positive infinity. And then the last one, the one we haven't seen, down would be f of x approaches negative infinity. All right, last part. We did a warm-up. There's a video for the warm-up. If you're watching the video at home, you need to watch the warm-up first to really understand the next part. Increasing and decreasing. The key to that warm-up was this. You looked at the y, but you reported the x's. You looked at the heights of that object, but you talked about the time. Okay? All right, so I want you to picture yourself on a roller coaster. You read a graph like you read a book. And here you are on that roller coaster. You're that star. Read a graph like you read a book. What are you going to be doing on this graph from left to right? You're going to be going down, then you're going to go up, then you're going to go down, then you're going to go up. So you go down twice, you go up twice. There's going to be 2 decreasing intervals and 2 increasing intervals. All right. You start with negative infinity and you finish with positive infinity because those are the x values on the x. You start with negative infinity and you finish with infinity. So this function, when it comes into view, so your first interval from negative infinity to what? From negative infinity to what? When does it stop decreasing? When it turns around. And it turned around at the point -1, -2. You look for the x. So from negative infinity to negative, it's decreasing. So I'll kind of chop the x-axis up and say, all right, we covered all of this so far. What does it do from -1 to the next turning point? It increases. So from -1 to 0, -1 to 0, from -1 to 0, it's increasing. Turns around again, and from 0 to 2.5, from 0 all the way to the next turning point, 2.5, it's decreasing. So from 0 to 2.5, decreasing. And then it turns for the last time. And from x value 2.5 to x value positive infinity, it increases forever. So your final interval, 2.5 to infinity. And if you want to put the positive in front of it, that's fine. So you look at the y's, but you report the x's. And it made more sense with the word problem because it was the time that it was going up and the time that it was going down. Okay? All right, so I'll stop the video here. I'll go ahead and I haven't decided if I'm going to record the example 2 or not, but at least on the video I'll let you see what it is. You could try it. I probably will record this at some point, but in class I want you to try number 2. I'll help you with anything you struggle with, but I just want you to try number 2 on your own.